Okay, welcome back. So in this particular video, we're going to find the present value where an initial amount would be deposited in an account that earns 4%, and it will be compounded semi-annually so that it will eventually accumulate to 16,000 in a period of 3 years. So this would be an example of a problem like what we're going to calculate today. And so what we're going to do, if dollars are to be accumulated in T years in an account that pays a rate R compounded N times per year, then the present value P that needs to be invested now is given by the following formula. So the formula that we're going to use is going to be P, which is the present value, equals the amount, okay, over 1 plus R over N, parentheses, raised to the NT power. A is the future amount, okay? So, well, the future value, but same thing, future amount. Okay, so this is the formula we need. Okay, so the amount we need today, or the present value, is determined by the present value formula, okay? So the future value A, okay, as we identify our information, A is going to equal 16,000. That's our future value. And then the rate is going to be 4%, which is going to give you 0.4. Okay, so you got to convert that to a decimal. All right, so let me see here. Okay, never mind. All right, so, and then also the time is going to be in 3 years. So this information is given in the problem, okay? So now what you got to pay attention to is how often this interest is compounded. Well, it's compounded semi-annually. So that key word represents twice a year, okay? So N is going to be 2. Okay, N is the number of times an amount is compounded. So in the formula, you'll see N twice, okay? So it's really important to read the problem and find out how much it is being compounded. That's really important because you're going to need that to plug into the formula that's given here in red. Okay, so let's substitute and let's get the value that we need. Okay, so P is going to equal, let me just use a different, okay, so P is going to equal, the A is going to be 16,000 all over 1 plus 0.04 over 2. And then that's going to be raised to the 2 times 3. So N is 2, multiply that by the time, which is 3 years. And then we just simplify using basic arithmetic, okay? So quarter to order of operations, you want to do what's in the parentheses first in the denominator. So what we want to do is clear this fraction, 0.04 divided by 2, and then add 1, okay? And that's going to give you 1.02, okay? So let's go ahead and simplify this. Okay, so the 1.02. And then of course that's raised to the 6th power, because 2 times 3 is 6. And then we're going to do 16,000 divided by 1.02 to the 6th power. So when you do 1.02, excuse me here, so is going to equal 16,000 divided by 1.1261. Now, when you calculate this on the calculator, when you do 1.02 to the 6th power, you're going to get this very long value, many, many decimal places. Keep those place values in the calculator. All right? So what you're going to do is you're going to take the 16,000 and you're going to divide by those numbers that we get. Okay? So here's what we're going to do. Okay, so let's go ahead and calculate this. I need to write that again. So when you do 16,000 divided by 1.261, etc., you will get a value of $14,207.55. That would be the amount that you would have to deposit in order to accumulate $16,000 with a 4% rate over 3 years. Okay? That's what you need. Okay, so pretty easy problem. Just have to, know how to read it, identify the information that's given, plug it into the formula, and do the arithmetic carefully. That's the, I would say that's the more the more difficult part in terms of being careful. Not that it's difficult math, but in terms of how you calculate things and the order and how to, make sure you're entering everything in the calculator properly. Okay? Other than that, it's a pretty straightforward problem. Okay? So, anytime that you're given those, that's kind of what you do. Now, let's go ahead and talk about the annual yield. Okay? So we are going to go to the next slide, and we're going to determine the effective annual yield. So let me just go ahead and, write this out. So this is the problem. What is the effective annual yield for each investment? Then select the better investment. So what amount are we going to get as a result based on two conditions or two situations? So here we go. It's going to be 15%. Okay, rate of 15%, 15.25% actually. That would be the amount that's going to be given. 15.25%, which is going to give you 0.1525 as a decimal. All right, n's going to be annually. Okay, so it's going to be compounded annually. So therefore, n is going to equal 2. Okay. All right, let me go ahead and write this more neatly here. All right, compounded annually. So therefore, n equals 1. Okay. So suppose that an investment has a nominal interest rate, which just means the rate before inflation is taken into account. And R is going to be in decimal form and pays compounded interest n times per year. In case this is 1. The investment's effective annual yield, Y, is given by this formula. Okay. Alright, so we have 1 plus R over n raised to the n minus 1. So we're going to find the effective annual yield for an investment at 15% that is compounded monthly. Okay, so that's the other situation. The first one is on top. Okay, so So let's look at another situation, and I'll explain why we're doing the other situation first, so it'll make better sense. We want to find the annual yield, okay? We want to find the annual yield, okay, at an investment rate of 15%. I'm just going to bullet point the problem. And it's compounded monthly. Okay. And of course, the rate is going to be, well, 0.15. You got to convert that to a decimal. Right, now we know n is going to be 12 because 12 months in a year. And then we're going to use the formula that's given here, okay, in red. So let's just plug in the numbers directly. Okay, y equals 1 plus 0.15 divided by 12. Okay, raised to the 12th power minus 1. Okay, and when we do all the math, just like before, we are going to get y equals 16.08%. So you notice that the first problem gives you the percentage, okay, which is the rate. And the second part of the problem says that the effective annual yield for this investment is going to be 16.08% when it's compounded every single month. Okay? If you look at the first problem, it's compounded one time, not 12. Okay? So what is the annual effective yield in 1 year? What is it per year? Okay? We're going to get that. Actually, it's given in the problem. Okay? The first problem says the annual effective yield, okay, is actually the interest rate, because every year that's what the effective annual yield is. It's already given, actually. So you don't even have to calculate anything, okay? The only thing we calculate is what is it when it's compounded every month? Well, what is it, what is it per month? Okay? So that's different than per year, okay? So for every single month it's compounded, your effective annual yield is 16.08%. So you want to calculate that first. So you compare it, what it is per year. Well, we already know it per year. It's already given, okay? It's annually, and the rate is, 15.25, okay? So all you do is compare it what the annual rate is, which is given, and then that is going to be compared to the annual effective rate per month, or compounded 12 times a year, okay? So when it's compounded 12 times per year, this is the effective annual yield, okay, that I underline. So what we got to keep in mind is now that the effective annual yield for the investment of 15.25 that is compounded annually, okay, it's going to equal whatever we get for this value here. Let me write this down so I can explain. Since the investment is compounded annually in this investment, it kind of sounds redundant. All right, the effective annual yield is the interest rate, 15.25%. Okay, that's what it is per year. So the first investment compound annually is 15.25%, because when we calculate this, you want to know what the yearly the yearly rate is, okay? Because that's what it is before it's compounded multiple times. All right. So when we compound it 12 times per year, the other one is 16.08%. That's the effective annual yield for that investment. But per year, it's 15.25. When you compound it more than that, then you're going to get 16.08. In this case, it's compounded 12 times. So now that for any rate R is compounded annually, the statement below is true. Okay? So basically, let me go to the next slide. So basically, you have, okay, so for any rate R, compounded annually, okay, this statement will be true. So that means the effective annual yield, okay, it's going to be this formula, 1 plus R over N 1, that's going to equal the rate. Okay, so since we said the rate is 15.25% per year, then if we plug it in, watch this. Okay, so you're going to do 1 plus, okay, R, no, we know the rate, let's plug it in. We said it was 0.1525, good. Yeah. N is going to be 1, raise that to the 1. So Y is going to equal that, which should equal R. So the Y should equal the R. The effective annual rate should equal the rate. The effective annual yield per year should equal the rate. So when you plug it all in, okay, you're going to get, 0.1525 divided by 1 is just going to be that 0.125. Okay, and when you add it together, you're going to get 1.1525. You raise that to the first power, okay, you will get, I forgot the, in order for the effective annual yield equal R, we got to add this to the equation, okay, minus 1. Okay, so this is going to give you 1.1525 minus 1. So anything to the first power is that same thing. And when you subtract 1, okay, you'll get 1.1525. So the effective annual rate yield is still going to be that annual rate, which it should be, right? Okay, so when you use the original formula, you notice it has 1 plus. 1 represents the initial amount that is given, and then you're adding an interest rate per year. So it should be 1 plus 0.125% per year. So it should be increasing. Okay, and that's what the first situation says. The effective annual yield is that rate per year, 15.25%. Okay, so the reason why we're subtracting 1 is I just want to know what the rate is, okay, for that effective annual yield. So whatever you get, whatever you start initially, and then you add that interest rate per year, okay, you got to subtract the original amount because I need to know what the original percentage is. Well, if you subtract the whole amount, the original whole amount, and you take that out again, that's the minus 1, then it should be left with the rate. Does that make sense? So So therefore, your effective annual yield, here it is, right here, okay, is going to be 0.125, and then that should equal the rate that's given, okay, which is 0.125. Okay, so this is the yield, and that's going to be the R. Okay, so that's why those two are equal. So which one is the better deal? Well, the annual yield for the first investment, the effective annual yield for the second investment is 15.25%. So that's for the first investment. If you do 15% compounded monthly, that's a better investment because the effective annual yield for the first investment is higher than the effective annual yield for the second investment. Okay? So the second one is the way to go. Okay, which is 16.08. Okay? All right, so, the first investment, okay, the first investment is at 0.1525. And when we calculated the second investment, sorry, I'm getting this backwards. It's really good. The second investment, which we calculated on the previous slide, right, is 16.08%. Okay, because the first investment is what it is per year. Okay, which is 15.25%. Okay. So when it's compounded monthly, this is the one that we want. That's a better rate. It's compounded monthly. So that's when n is equal to 12. And then this guy is going to be when n equals 1. Okay. And by the way, the effective annual yield is the total profit or returns on a bond that an investor receives. Okay? So I hope this video was somewhat helpful to you. I know it's a lot of information and a lot to think about, but you're just comparing two annual yields here. Okay? So regardless of where you start, I mean, you got to do the one that's 12 months. You need that one to compare it to the annual yield per year. Okay, well, I'll see you in the next video. Thank you.